Hello students, in today's video we will do course code 0625 paper 2 Feb March 2025. Question number 1 says the diagram shows 3 force acting on an object, 9 Newton towards right, 1 Newton and 6 Newton. What is the magnitude of resultant force acting on an object? So 6 Newton force is acting upside, and there are two forces acting right and left that will cancel the effect of each other, and only 8 Newton of force will be left, which would be acting towards the right side. So 8 Newton force acting towards right side. Now what is the resultant force? For resultant force we can calculate the hypotenuse of this triangle, and we can use Pythagoras theorem for this. A is 8 and B is 9. So 8 square plus B square, which is 6 square. And the final answer would be 10. That means resultant force is 10 Newton. Question number 2 says, which rule defines speed and velocity? Speed is a scalar quantity and velocity is a vector quantity. A scalar quantity has magnitude only, and a vector quantities have magnitude and direction both. So for speed, we only need the magnitude, or we need the distance traveled per unit time. But for velocity, we need the direction as well. So B is the correct answer. Question number 3 says the diagram shows the journey of a motorcyclist. Which sector of the graph shows the time when the motorcyclist is stationary at some traffic lights? Stationary means at rest, or we can say it means when velocity is 0. At position C, the value of velocity is 0. That means at position C, the motorcyclist is at rest. Question number 4 says the acceleration of a free fall on the moon has 1/6 of its value on Earth. On Earth, the astronaut mass is measured to be 60 kg. Which row shows the mass and weight of the astronaut on Earth and on the moon? The value of g, or acceleration of free falling object, on Earth is 9.8, and on moon this value is 1/6 of its value on Earth. That means it would be nearly 1.63. And the mass of the object is the quantity that never changes. No matter we go on space or we are on Earth, it never changes. That means if the mass on Earth is 60, it would be 60 and the moon as well. And the weight is defined as mass times gravitational acceleration. If mass is constant, weight is directly related to the gravitational acceleration. So if gravitational acceleration reduces, weight also reduces. That means on moon the weight would be less. So out of B and D, the option D is correct because the weight is reducing from 590 to 98. D is the correct option. Question number 4 says the load extension graph for a material is shown. Which point indicates the limit of proportionality? Load extension graph can be defined by using Hooke's law, which says that extension produced in an elastic body is directly proportional to load applied. That means their graph would be a linear graph. But there comes a point in this linearity graph where the linearity or direct relation does not exist anymore and the graph starts curving itself. This point is known as limit of proportionality. And in the question or the graph we have, after point A, the graph started curving itself. That means A is the limit of proportionality. Question number 6 says an object of mass 4 kg is moving with velocity 3 meter per second. What is the momentum of the object? Momentum is defined as product of mass and velocity. The value of mass is 4 and velocity is 3, so momentum is 12 kilogram meter per second. Question number 7 says a tall cylinder is partly filled with two liquids which do not mix. The two liquids have different densities. A student measures the pressure due to liquid at different depths. We will study the change in pressure of the object from position P to position Q. The pressure has the equation rho g h. H is the depth. When depth of the object increases, the pressure increases, and rho is density. When the density of the liquid increases, the pressure increases. Which graph shows the liquid pressure varies between point P and Q? The liquid that is above would have a lower density than the liquid that is below, and when the object starts sinking from the first liquid, its pressure increases due to the increase in depth. But when it enters the second liquid, the density also increases. That means the change in pressure would be even more than before. We are not considering the option D because in it the pressure is same throughout, which is not true because height and density both are changing. We are also not considering the option C because in it the pressure change is very linear, which is not true because in its journey the object enters a liquid of greater density and which drastically increases the change in pressure, which is not mentioned in this diagram. So this is not the option. In option A, from this P point till here, it is the journey of the object when it's moving in the lesser density medium and the pressure is increasing due to the increase in depth. But after this point, this is the journey when the object enters a greater density liquid and its pressure should increase because the density is increased. But over here, the slope is being reduced. That means pressure is being reduced after this point, which is not correct. Option B is correct because the second line is more slopier than the previous line, which shows that the pressure is increased when it enters greater density. Question number 8 says the tennis ball with momentum 2.3 is struck by the tennis racket. The racket causes the direction of motion of the ball to reverse. The racket exerts an average force of 1500 Newton during the impact with the ball. The racket and the ball are in contact with each other for 0.0024 seconds. What is the magnitude of momentum of the ball when it leaves the tennis racket? There is a racket and the ball is traveling towards the racket with the momentum of 2.3 kilogram meter per second. And after striking the racket, the ball returns back with the final momentum that we have to calculate, and the ball is in contact with the racket for 0.0024 seconds and the racket exerts force of 1500 Newton on the ball. We can use the formula impulse is equals to change in momentum. Impulse is the product of force and the time for which the force acts, and change in momentum is final momentum minus initial momentum. Note that the direction of velocity is reversed. So if we consider this direction as negative, the other direction would be considered as positive. So now I'll plug in the values. Force is 1500 and the time period for the force that is 0.0024 seconds. So 0.0024 is equals to final momentum, which is not known, we need to find it, minus initial momentum. Now what is the initial momentum? It's 2.3, but I will include the sign of the velocity as well, so it would be negative 2.3. Multiplying these two values together, I will get 3.6 is equals to final momentum minus minus would be plus 2.3. Now if we want to get the final momentum, I will rearrange the equation and it would be 3.6 minus 2.3, and after subtracting it we will get 1.3, which is the final answer. Question number 9 is saying a car is traveling at the speed of 8 meter per second. The kinetic energy stored in the car is 32,000 joules. What is the kinetic energy stored in the car when its velocity is increased to 16 meter per second? Firstly, I will use the above given two informations to calculate the mass of the car. Kinetic energy is half mv squared. To get the mass, I'll rearrange the equation and it would be 2 times kinetic energy over v squared. Now I will plug in the values. It would be 2 times the value of kinetic energy is 32,000. So I'll plug in 32,000 in place of kinetic energy over v squared. Velocity is 8, so it would be 8 squared. Calculating it, the value of mass will turn out to be 1000 kg. After getting the mass from this information, we can use it in the second information to calculate the kinetic energy. Again, kinetic energy is half mv squared. Plugging in the values 1 over 2 in place of m, I'll write 1000. V is 16 squared this time. And doing the calculation, the kinetic energy would be 128,000. To two significant figure, it would be 130,000. Question number 10 says, the sun is not the primary source of energy for which of the resources? For oil, we need sun because oil is produced by plants and plants get their energy from sun by photosynthesis, so it's not the case. Tides can be the option because tides are produced by the gravitational pull of moon, so they can be considered because they don't need energy from sun. Question number 11 says an experiment is done to compare the rate of conduction of thermal energy in metal and plastic spoon. The ice cube is placed at one end of the each spoon and other end is heated. So there is a spoon which is made up of metal first and the heat is supplied and the energy will travel in this direction to melt the cube, and again in plastic spoon the heat will travel in this direction, but the travel of heat in case of plastic is slow because plastic is a bad conductor of heat, and in case of metal it would be fast because metal is a good conductor of heat. So option number A, which says the metal is good conductor, so metal ice cube will melt fast, is correct. So option number A is the correct option. Next question says four students determine the efficiency of four different electrical appliances. One of them is wrong. Which student is wrong? So student number D is wrong because maximum efficiency of any device is 100% and it can't exceed 100%. She has written 102, which is wrong. Question number 13 says a sample of a gas is sealed inside a container of fixed volume. The temperature of the gas is increased. Which statement explains why pressure of the gas increases? Basically, we have a container in which we have gas of fixed volume, and the molecules of gas are constant motion and randomly moving here and there. We supply heat to this container, that means we increase the temperature of this container. The increase in temperature will cause the molecules to move more quickly and more frequent collisions with them would happen, which will increase the pressure. So the pressure increased because the molecules are colliding more frequently with the walls of the container. B is not correct because it is saying mass is increasing. No, the volume is constant, so mass do not increase. C is not correct because it is saying the number of particles increases. Again, no, volume is constant. And D is not correct because it is saying the time between collision increases. No, the collision become more frequent, so time decreases. Question number 14 says a student does an experiment to determine specific heat capacity of a metal block. The energy is 12 kilojoules, initial temperature is 20 degrees centigrade, final temperature is 45, and the mass is 600 gram. What is the specific heat? The formula for the specific heat is this. For change in energy, it is 12,000 joules. So I'll put 12,000. And m is the mass, and the mass of the block is 600 grams. We need to convert it into kilogram. We'll divide it by 1000, so it would be 0.6 kg. In place of m, I'll write 0.6. Now what is change in temperature? Change in temperature can be calculated by subtracting final temperature and initial temperature. So 45 minus 20, the change in temperature is 25 degrees Celsius. When change in temperature, I'll put 25 degree Celsius. Now I'll do the calculations and it would turn out to be 800. So option D is correct. Question number 15 says a metal block is left overnight in cool and shady room. In the morning, the block is moved into a warm surrounding. Which statement about the metal block is correct in the morning? So there is a metal block who is left at night in cool and shady environment. That means its temperature is low. And when you shift this metal block into a warm surrounding, that means around the block the temperature would be high. Now, this is a rule that temperatures start moving towards lower temperature from higher temperature. So temperature will start shifting towards the block and the temperature of the block or the box will start increasing. and the internal energy of the block will also start increasing because of the temperature. So the correct option is option number A, the internal energy of the box will increase. B is not correct because it's saying temperature decreases. No, the temperature of the block increases. C says it's convection transfer energy. No, it's transferred by conduction. And D says the metal slightly contracts. No, it expands. Question number 16 says a fixed mass of gas is contained with a sealed syringe at pressure 100 kilopascal. The plunger is slowly moved until the pressure is 80 kilopascal. The final volume is 50 centimeter cube and the temperature do not change. What is the volume of gas before the plunger is moved, or means the initial volume? So initially the pressure is 100 kilopascal, so let me call it P1. And after it the pressure changes to 80, let me call it P2. The final volume is 50, so it's V2, and we have to get the initial volume, that means V1. The temperature is not changing, so we can use Boyle's law, which says PV is constant. So P1 V1 is equals to P2 V2. If I want to get V1, I'll rearrange it and it would be P2 V2 over P1. Now I will put the values. In place of P2, I'll write 80. In place of V2, I'll write 50. And in place of P1, I will write 100. Solving this, the initial volume, or V1, would turn out to be 40 centimeter cube. Question number 17 says the diagram shows more energetic water molecules escaping from the surface of the liquid. And what is the name of this process? So moving of water molecules from surface is known as evaporation. Question number 18 says a hot objects emit thermal radiation. Which row describe two changes that both reduce the rate of emission of radiation? So if an object is hot, that means its temperature is high and it is emitting thermal radiation. The radiations are emitted from the surface. So to reduce the amount of radiations, we have to reduce the surface area of this block. So firstly, the surface area should be reduced, and also the radiations are being emitted because the temperature of the surface is very high and it is moving towards lower temperature. So to reduce the amount of radiation, the temperature of the surface of the block should be reduced. So the option D is correct. We have to reduce the surface area and the temperature of the surface. Question 19 says the frequency of the wave is doubled and the speed of the wave does not change. What happens to the wavelength of the wave? We can use wave equation to describe this. V is equals to F lambda. To get F, it would be F is equals to V over lambda. The question is saying that velocity is not changing, so V is constant. That means we can replace V with the proportionality sign. So frequency is inversely proportional to wavelength. If the frequency is changed by the factor 2, wavelength would also be changed by a factor 2. So if frequency is doubled and I rearrange the equation, the wavelength would be halved. So answer number D is correct, wavelength halves. Question number 20 says, which statement about ultrasounds is correct? A normal human ear can hear the frequency ranging from 20 Hz till 20,000 Hz. And any frequency which is greater than 20,000 Hz is not audible to a normal human ear and it is considered as ultrasounds. So ultrasounds are the sound waves which have frequency higher than 20,000 Hz or frequency higher than audible sound. Also, ultrasounds are the sound waves, and sound waves are longitudinal waves. So, option number A is correct. Question number 21 says, which statement about the image produced by plane mirror is not correct? This is the image produced by a plane mirror. The rays that fall on mirror are reflected back and you extend the rays to make an image. The image is same distance from the mirror. The image is virtual because we produce it by extending the lines, and the image is same size. So option A is the answer because they are saying the image is real, but no, the image is virtual. Question number 22 says a ray of light incident on the boundary between air and water, under which condition the ray of the light is totally internally reflected. Total internal reflection has two conditions. Firstly, the ray should move from denser to rare medium, and next condition is angle of incidence should be greater than critical angle. So the first option is saying the ray initially in air is entering into the water. That means from rare to the denser medium, which is not the option. Option number B is saying again the ray is entering from air to water, which is not the condition for total internal reflection. So B is also not correct. Option number C is saying the ray is entering from water, that means more denser medium, to air to less denser medium, which is correct. But at any angle of incidence, it is wrong because angle should be greater than critical angle. Option number D is saying the ray is entering from water into the air and angle greater than the critical angle, which is correct. So option number D is correct. 23 says a converging lens is used to make image on the screen. This candle will fall light on this converging lens and this lens will make the image on the screen. Which type of image formed on the screen? If we see the image formation by convex lens, we see that whenever the image is formed on the opposite side of the object, always the image is real and inverted. In first case, second case, and third case as well. But when the image is formed on the same side of the lens, the image is virtual and it is upright. In our case, the image is formed on the opposite side of the lens, so it would be real and inverted. Question number 24 says a negatively charged rod is brought near to a metal sphere. A positive charge develops on the surface of the metal sphere closer to the negative charged rod. Why is this? Initially, the rod is neutral because positive and negative charges are equally spread. But when you bring the negative rod near, the negative rod will attract the electrons towards itself and metal sphere will look like this. So option number B is correct, which says that electrons in sphere are repelled by negatively charged rod. Question number 25 says the electromotive force EMF of a cell is defined by which quantities? So if we have a circuit and there is 1 coulomb charge which is full of energy when it leaves the circuit, and in its route around the circuit it will use its energy in the components and in form of heat, and when it reach back to the battery its some of its energy is consumed. So EMF is the amount of energy 1 coulomb of charge consumes or the battery supply to the charge to move around the circuit. So it's energy transferred by the cell in moving charge around the circuit. So option A is the answer. Question number 26 says a resistor of resistance R is connected to a battery of electromotive force V. There is a current in a resistor. Power P is dissipated by the resistor. In time t, the energy transferred is E. Which expression is correct? Power is defined as energy supplied per unit time, and power is also defined as the product of current and voltage. So if I put here the value of power, which is IV, the equation will turn out to be IV is equals to E divided by T. Now if we want to arrange it, it would be E equals to IVT, and this equation is similar to equation A, so this is correct. 27 says a copper wire of length 80 cm and cross-sectional area 0.2 has radius r. Which length of copper wire of cross-sectional area 0.2 has the resistance r? Resistance is directly proportional to length of the wire and inversely proportional to cross-sectional area of the wire. And according to the question, in both cases the resistance is same. Let me call it R1 and R2. So R1 is equals to R2. Now I will put the equation of resistance, which is L over A. So L1 over A1 equals to L2 over A2. We want to find L2, so I'll rearrange the equation. It would be L2 is equals to L1 over A1 times A2. Plugging in the values, L1 is 80 over A1, which is 0.2, times A2, which is 0.4. When you will do the calculations, the second length would be 160 centimeter. Question number 28 says, four identical resistors are connected to battery as shown. Each resistor has the value 120 ohms. So this is the circuit, and the question is saying the resistance R is removed. Which effect does removing the resistor have on effective resistance of the circuit? So this R2, R3 and R4 are connected in parallel. So let me calculate their effective resistance first. It would be 1 over RT is equals to 1 over R2 plus 1 over R3 plus 1 over R4. Now I will plug in the values of R2, R3 and R4. It would be 1 over RT is equals to 1 over 20 plus 1 over 20 ohms again, and for R4 it would be again 120. Doing the further simplifications, it would be 1 over RT is equals to 3 over 120, and the final effective resistance would be 40 ohms. So RT is equals to 40 ohms for this three R2, R3 and R4 which are in parallel. Now, if I want to get the effective resistance including R1 also, the circuit will look like this. This is the effective component of R2, R3 and R4 which is 40 ohms, and this one is R1 which is 120 ohms. So the effective resistance as they are in series would be 120 plus 40 ohms. So effective resistance would be 160. Now the question says, what happens if we remove this fourth resistors from our circuit? Now what will happen to the effective resistance? Now we will calculate the effective resistance again. R2, R3 are in parallel, so their effective resistance would be 1 over RT over 1 over 20 and 1 over 20. And it would be 1 over RT is equals to 2 over 120. And when we'll do the calculations, the effective resistance of R2 and R3 will turn out to be 60 ohms. So this is 60 ohms. Now again, if we see this with R1, this effective RT60 value would be in series with R1, and the value of R1 is 120 ohms. Now what is the effective resistance of these two? As they are in series, effective resistance would be 120 ohms plus 60, and the value of RT would be 180, the effective resistance without R4. So you see, without R4, the effective resistance is increased by the value of 20 ohms. Question number 29 says the resistor in circuits shown are identical. The reading on voltmeter V2 is 1.5, emitter A2 is 0.5 and emitter A3 is 0.25. What are the readings on emitter A1 and voltmeter V1? This is positive terminal of the battery and this is negative. The current will flow from the positive terminal and it will reach the emitter A1. And after emitter A1 it will reach the junction, after which it will split into A2 and A3. That means A1 is going to read the full current before splitting. The value of A1 would be A2 plus A3. So I'll put the values. A1 is equals to the value of A2 is 0.5 and the value of A3 is 0.25. That means A1 has the total reading of 0.75 amperes. Now, what is the voltage V1? You know, the voltage across the voltmeter V2 is 1.5 volt, and the other resistor which is connected beside it is identical to it, so its voltage would be also 1.5 volts. As they both are in series, so their combined voltage Vt would be 1.5 plus 1.5, which is 3 volt. So combined voltage across this junction is 3 volt, and as this is parallel, so the voltage would be same as supplied by the battery. That means the V1 would also be 3 volt. So answer D is correct, in which current is 0.5 and the voltage is 3. Question number 30 says a wire is moved in the region between the poles of magnet. A current is induced in the wire. In which direction is the wire moved? So if for the induced current, we can use Fleming's right hand rule. For this, the direction of magnetic field is from north to south. So I am pointing my forefinger in the direction of magnetic field. The current is downward, so my middle finger is downward, and the direction of my thumb or force is into the page. So C is the correct option, which is saying perpendicularly into the page. Question number 31 says a fixed resistor is connected in secondary coil of step-down transformer. The transformer is 100% efficient. The variable resistor is adjusted so that the current in fixed resistor is decreased by 0.25 ampere. What is the change to the current in primary circuit? The transformer is 100% efficient. That means the power in primary coil would be equals to the power in secondary coil. And power can also be written as product of current and voltage. So IPVP is equals to ISVS. Now, if the primary voltage is 240 and let us assume that the primary current would be 3 amperes, I am assuming the values. So power would be V times I. So 240 times 30 would be 720 watt. So power is 720 watt for primary coil. Now for secondary coil, let us assume that the secondary voltage is 24 volts. What would be the power, as it's 100% efficient, so power would be same again, it would be 720 watt. What is the value of secondary current? To make the power 720, I'll multiply 24 with what value of current? The value of current would be 30 amperes, because 24 times 30 would be 720 and the power would be 720 again. But they are saying the value of secondary current is decreased by 0.25. That means IS is 30 minus 0.25, which would be 29.75 amperes. Now what will this decrease in current do to the current in primary coil? Let me put the other values as they are. Vp is 240, Vs is 24. What will be Ip or current in primary coil now? For this I can use the equation IPVP is equals to ISVS. To get the value of Ip, I will write ISVS over Vp. Now plugging in the values, IS is 29.75 and Vs is 24 and Vp is 240. When I'll do all this calculation, the IP would be 2.975. Originally it was 3 amperes and it is reduced by 0.025 amps. So answer B is correct, which is saying the value of IP is decreased less than 0.25 amperes. Question number 32 says an electrical device changes the voltage of an electrical supply from 240 to 20 volt. What is this device? This device is surely a transformer which is used to increase or decrease the voltage supply. Question number 33 says an AC generator is set up so that its coil of wire is perpendicular to magnetic field. The coil of wire is rotated slowly to produce AC current and EMF. A graph of induced EMF against time is plotted as the coil rotates. So this is EMF and this is time. This from O to S is the complete cycle of the coil when it's rotating. Which section of the graph represents the rotation of 3/4 of a turn? 3/4 means 3 by 4. For from O to S, this is a complete rotation of the coil and it is divided into 4 parts. From O to P first part, P to Q second, Q to R third, and R to S fourth part. So 3 by 4th means 3 portions till R. So C part is correct. OR is 3 by 4th. Question number 34 says a uranium nucleus decayed to form thorium by emitting alpha particle. Thorium decays to protactinium by emitting a beta particle. Which row gives the atomic number and mass number of isotope of protactinium? So firstly we have uranium with mass number 238 and atomic number 92, and this is going to emit an alpha particle, which is helium particle, with mass number 4 and atomic number 2. Along with it, it will make thorium. So what are the atomic number and mass number of thorium? For this we can balance the equation. 92 is equals to 2 plus dash, which is atomic number of thorium. What added to 2 makes 92? This is 90. So atomic number of thorium is 90. Then again 238 is equals to 4 plus dash, which is mass number of thorium. What added to 4 makes 238? It is 234. So mass number of thorium is 234. Now this thorium 234 and 90 is again going to emit a beta particle, and beta particle is basically an electron and it will form protactinium. So it will emit an electron and it will form protactinium. Now, how can we find the mass number and atomic number of protactinium? We again will balance the equation. What added to minus 1 will make 90? It is 91. So atomic number of this is 91. And 234 is equals to 0 plus dash. What added to 0 makes 234? It's 234. So mass number is 234. So answer is C with atomic number 91 and mass number 234. Question number 35 says which row shows what happens when nucleus decay beta particle. Beta particles mean emission of an electron. Now we have just done an example of it. When electron is emitted, you see that the atomic number is increased by 1. Now where does this proton came from? This proton is basically formed by a neutron. A neutron converts itself into electron and proton. So option number A is correct, in which neutron changes to proton and electron. Question number 36 says which precaution does not always reduce the scientist exposure when working with source of ionizing radiation? Option D is not correct because it's saying placing a lid shield, which is a very good protection. C is saying limiting the exposure time, which is a very good precautionary measure. B is saying increasing distance. Again, it is a very helpful method to reduce the damage. Working with long half-life resources is a bad idea because long half-life radioactive materials emit radiations for longer period of time. Question number 37 says a detector is placed near a radioactive isotope and it records 700 counts per minute. Half-life is 8 minutes and the average background radiation is 60 counts per minute. What is the count rate measured by detector after 16 minutes? So 700 is the count rate measured by the detector, which includes 60 counts of environment as well. So what is the original count? It is 700 minus 60, which is 640 counts per minute. How many counts would be after 16 minutes? How many half-lives are there in 16 minutes? 16 divided by 8 is 2. So there are 2 half-lives in 16 minutes. So original radiation count is 640. After first half-life, the count would be halved, which is 320 counts per minute. After second half-life, it would be 160 counts per minute. But we have to measure it by detector, and detector also measure the background radiations, which is 60 counts per minute. So you have to again add this 60 counts per minute to our reading. So 160 plus 60 is 220. So 220 counts per minute. Question number 38 says a nucleus of nitrogen absorbs a neutron. It then decays into an isotope of carbon and emits X. What is X? Now we can balance this equation to know mass number and atomic number of X. 0 plus 7 is equals to 6 plus atomic number of X, which is unknown. 7 this side, what added to 6 will give you 7? 1. So atomic number of X is 1. Now doing it for the mass number, 1 plus 14 is equals to 14 plus mass number of x, which is unknown, so a blank. 1 plus 14 is 15. What added to 14 will give you 15? 1. So mass number is also 1. Now, if we compare, alpha particles are helium particles which have mass number, atomic number 2 and 4. This is not the option. B is beta particle which are electron, and gamma particles which are neutral. So D is the correct option. Question number 39 says a graph shows how the strength of Earth's gravitational field varies as the distance from the Earth's surface increases. So when we are moving away from the Earth, the distance is increasing and the gravitational field strength is reducing. Which row describes the effect that this has on mass and weight of an object as we move away from the Earth's surface? Mass is not changed wherever you go. So mass remains unchanged. C and D is the option that we can consider. Weight is equals to mass times gravitational acceleration. If mass is not changing, weight is depending upon G. If G is reducing, weight will also reduce. So C option, in which weight is decreasing. Next question says a student plots a graph of the speed of different galaxies moving away from the Earth against distance from the Earth. Over this side we have speed and over this side we have distance. Use the best straight line shown on the graph to calculate the Hubble constant. Hubble constant is equals to speed of the galaxy over distance of the galaxy from Earth. I can take this point, this is the value of x and y over this point. Putting the values in equation of Hubble constant, V is 20 million and the value of D is 1 into 10 raised to power 25 meter. Now when I'll put this into my calculator, I will get 2 into 10 raised to power negative 18 per second. So option A. Thanks for watching the video. If it was helpful, please hit the like button and subscribe my channel.